being recorded. Are there any questions? Anything? Any questions? Before break, we did a t-test. T-test for one sample, t-test for paired samples, and independent samples t-test. You can think about those tests, connect those tests with your project. So what kind of topic you are going to use t-test? Okay. Do we have any assignments today? Each class, we have a hands-on participation mark exercise. Okay, total 10%. So yes, we do have hands-on. Okay. After my lecture, I will give you hands-on. Other questions? Okay, so before the break, we did a test for one population, two populations. Now I'm going to compare population means for three populations. Okay? That is unit 7. Anova test, unit 7. There are many lessons in this unit. I will see how far we can go, but at least we are going to do lesson 25, one-way analysis of variance Anova. Okay. One-way analysis of variance is to compare 3 or more population means. So there are some assumptions you can go through. One is dependent variables are normally distributed. And the variance are the same for all populations. That is assumption 2. Assumption 3, data are random data. Okay, data random data. For the effect size statistics, we usually use the eta square. Okay, eta square equal to 0.01. That is the small effect size. If it is around 0.06, medium effect size. If it is 0.14, it is a large effect size. Okay. All right, so the data file we are going to use is lesson 25. There are 3 groups of people. Group 1 are given placebo. Group 2 are given low doses of vitamin C. Group 3 given high doses of vitamin C. So 3 groups of people. And what we are going to do with those 3 groups of people, we are going to say number of days with cold symptoms in the second year minus number of days with cold symptoms in the first year. Let me double check. So that is the meaning of another variable, okay, difference. And we want to say if this difference the same or different across the 3 groups. There are 3 groups, okay? We measure the difference variable to see if they are the same or not the same. Normally, I'm going to copy this because I want to explain the hypothesis test. Here we have 3 populations, okay? So we use the mu1, the mean for population 1, mu2, mean for population 2, mu3, the mean for population 3, and our hypothesis is H0, all the means are equal. All 3 population means are equal, okay? And alternative hypothesis, because we have 3 means we have to, the opposite of H0, we are going to say at least 1 mu I is different from others. So I'm going to type in, okay, at least. One mu is different from others. So that is our H1. Okay, so now I'm going to open the data. So this is a lesson 25. So I already explained the data. We have 3 groups. Those are just a sample. Okay, this is group 1. Behind group 1 sample, you have population. And we want to see if the population mean for group 1 is the same as the population mean for group 2 or the population mean for group 3. We want to test the population mean. Hypothesis test is always targeting population. Okay. So to do that, we'll do this. Analyze general linear model univariate. Dependent variable is this difference, is our dependent variable. And the group is our factor. We have 3 groups of people. Okay. And now, under the options, usually we will select descriptive statistic, estimate of the effect size, homogeneity test. Homogeneity test is to make sure, remember one of the assumptions is that population variance are the same across different groups. So we selected those items, and now for the post hoc, okay, quick continue. For the post hoc, post hoc. Yes, we selected to the post hoc test for group. And if equal variance assumed, usually we pick REGWQ and 2K. If equal variance not assumed, usually we pick the donut C. You can choose other items. Okay. And now, quick continue, and then quick OK button. Okay. So this is the result. Okay. I'm going to copy this result into SPSS to make annotation. Maybe I need 2 screens. Univariate. And then we need this one here. All right, so this is our output. Remember we have 3 groups. Group 1, placebo. The mean is 3.5. The other group is low vitamin C. The mean is negative 2.1. The third group, high vitamin C, the mean is negative 2. Our task is to test if mu1 equal to mu2 or equal to mu3. This is our H0. Okay, we want to say if behind those means, remember a sample mean. Our test is targeting population. We want to see if 3 population means are equal or at least one population mean is different from others. Okay. And the Leibniz test of equality of error variance. So Leibniz test is to test if population variance are the same or different. There are some criteria based on mean or based on median, etc. Usually you can just select based on the mean. Okay, based on the mean. If it is based on the mean, Leibniz test p-value 0.278. This p-value compare alpha is greater than alpha. When p-value greater than alpha, equal variance is assumed. It is equal variance. Okay. So this is a Leibniz test. And then we have this test between subjects. And this is usually our Anova table. Okay. And from here, you have the test statistic for the model. It is use F test, and also you have the p-value for the model. And this p-value greater than this p-value smaller than alpha. So this model is significant. So when p-value smaller than alpha, the model is significant. Okay. And then you have, let's see, you have partial eta here somewhere. I see. Partial eta. The partial eta for the group is 0.264. What does the partial eta measure? Remember the partial eta, you have a small side effect 0.01, 0.06, 0.14. And our eta square value is 0.2. So it has the large effect size. Large effect size. And if you translate this number to percentage, it is 26%, roughly 26%. Okay, so the main effect, there is a significant main effect. And this is also proven by this p-value for the group. It is significant. There's a significant main effect for the group. Okay. So those are some, if you reject H0 in favor of H1 said at least one is different from others. And then you are going to make post hoc to make pairwise comparisons. You compare every 2 pairs. For example, you compare placebo group with the low vitamin group and compare placebo group with high vitamin group, and you got those statistics, etc. Okay. So any questions on the procedure for the Anova test? Anova test. And so this test, obviously, the three means are different. They are different. Okay. And if you produce the box plot, you can do this to examine the three means. Okay. You go to graph, legacy
participant is now joining.
Legacy dialog, and then click the box plot. And now you select simple, and then summaries for group of cases. Group of cases, quick define. So the variable is a different. Group is the category access. You want to produce the box plot for three groups. So this is the box plot. The mean value for group 1 is here. I need to copy this to OneNote. So this is the mean value for group 1, median. This is the mean value for group 2, mean value for group 3. By just visual visual investigation, so those are different means. Those are different means, okay? So there was a significant difference in the means between group received low vitamin C and high vitamin C and placebo group. You see those, if you only look at these two means, there's significant difference. Okay, so that is how we compare 3 or more population means, 3 or more population means. And there is an important table here. Mean square. This table is pretty much, sometimes we call this the Anova table between groups. So this is, let me see here. Yeah, this table is very important here. And when you did statistics, you should know the relationship between this mean square and the sum of total square. If you use 105 divided by 2, you get 102. Those are the relationship, okay? So for example, use 573 divided by 27, you get this value. Okay, and this is the mean square and the sum of squares. And how you get this F value? You actually use this 100, the mean square for the group 102.7 divided by 21. The mean square for the error, you get test statistic. So those are some, especially this one, are important equations in this table. Okay. All right. Any questions? Anything? Any questions? Okay, now I'm going to give you the in-class exercise. It is expected to complete in class, just a very small exercise. When you complete, you submit to Sakai. I haven't created a folder yet, but I'm going to give you the question first, then I will create a assignment link so that you can submit. Okay. So let me see this assignment. Maybe I'll just maybe instead of let me stop recording first because the lecture ends. I want to see, are there any questions about lecture? We no longer have 24 hours. Usually it is in class. If you need extension, I'm fine with that. Okay. Especially when you use the Windows Virtual Desktop to access SPSS. Okay. How about midnight? Due midnight? Okay, that's fine. So let's say due midnight of today. Okay, due midnight of today. Okay, let me stop recording first, just to save some cyber resources. Stop recording. I hope we have 3 recordings today. Okay, I hope. Stop recording.